Good evening. My name is Lee Costello, and I'm the lead front-end engineer at RubiconMD. Thanks for having me. Tonight, we're going to discuss using GraphQL in an Angular application. I'd like to briefly start with the problems in our market that we at RubiconMD set out to solve, the software challenges that came with this, and how that led us to GraphQL as part of our solution. Then we'll move to the basics of what GraphQL actually is, and finally on to how to use it in an Angular application. In America, healthcare is faced with many issues, especially access to care. 40% of visits to a medical specialist are avoidable. Even more concerning, 52% of the US lacks easy access to specialty care, and patients can face over a year of wait time to see high-demand specialties. RubiconMD has developed a platform to allow primary care providers to submit e-consults to top specialists and receive responses within hours. We are a mission-driven company, and our platform has opened healthcare access to portions of our population that need it the most. But developing software in the healthcare space brings some very interesting challenges. Healthcare has had many troubles with technology and is incredibly slow with adoption. For example, our old friend Internet Explorer is very much alive and well in healthcare, and hardware and connection speeds can be dreadful. These challenges make performance very important. Also, healthcare data is extremely sensitive. This is some of people's most personal information, and legally must be handled very specifically. When, how, and how much data our application requests has great implications. This issue cannot be overemphasized. It is a huge concern in healthcare. While always looking to improve how we handle these issues, we added GraphQL to our tools. So GraphQL was developed internally by Facebook in 2012 and powered their mobile apps. It was publicly released and open sourced in 2015. And actually, just this month, it was moved to the GraphQL Foundation, which is hosted by the Linux Foundation. So what is it? GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. We'll look through that definition in two parts. I've also created a sample application that I'll use for some examples. It has a simple Node.js backend, mock data, an Angular front end, and of course uses GraphQL. It tracks sales staff and clients for, let's say, a small paper sales office. The first part of the definition to look at is GraphQL is a query language for APIs. It being a query language at least gives us the QL portion of GraphQL, and it's a very important part of the specification. It defines a schema definition language, you'll see abbreviated as SDL throughout some of docs, that is used to write queries and mutations. Queries are a way to fetch data, think GET requests in REST, and mutations are a way to modify your data. You can think of put, post, or delete in REST. So we can retrieve data with a query, or we can modify it by creating, changing, or deleting with a mutation. When you query for data, you ask for what you need and get exactly that. GraphQL queries always return predictable results. This allows apps to be fast and stable because they control the data they get. On the left, we have a query written in GraphQL's SDL, and we are querying for employees and want their first and last name only. Looking at a response on the right, that's exactly what we receive. Nothing more and nothing less. If you remember in my real-world use case with RubiconMD, health data is very sensitive. Maybe I don't want to get the names of these employees and only want the ID. I can write my queries to get just that. This isn't only useful for healthcare. Even if data isn't sensitive, but it often is, for performance reasons, requesting and receiving only the data you need can be a big boost. It will make resolving the data quicker, the requests smaller, and keep our code laser focused. You can also receive many resources in a single request. GraphQL queries access not just the properties of one resource, but also smoothly follow references between them. The mock data in my application has circular references and is not necessarily stored together. Our employees objects contain a list of clients, but clients are separate objects and are stored elsewhere. Instead of needing to fetch your employees and clients from different endpoints and receiving everything, you again just specify exactly what you need. We don't want all of the clients, just the company name of the clients of these employees. Now let's briefly look at the second part of the definition. GraphQL is also a runtime for fulfilling those queries with your existing data. For this part, we'll focus on the server side just to get an idea of what is going on. GraphQL provides a runtime to receive the queries we just discussed, but how it handles them is interesting. You are not limited by a specific storage engine, database, or language. If we look at a previous example, there's no hints on where the response data is coming from, which is good. The employee's name may come from an internal database, but the client's company name may come from a separate database, or maybe even some third-party API. This doesn't matter for GraphQL, and all this data can be requested at once. Server-side, you write resolvers, which are functions to know how to retrieve specific data when requested. The GraphQL runtime will receive the queries, delegate out to the appropriate resolvers so your existing data is retrieved, and then responded with exactly the requested data. Another portion worth noting is that you describe what is possible with a type system. GraphQL APIs are organized in terms of types and fields, not endpoints. We can use a single endpoint to access all of our data, and types are defined to ensure that the applications only ask for data that is possible. This also creates really clear and helpful error messages. Looking at this example, you can see how our query for employees will be resolved to specific types and is very predictable. This is really great for when we define our schemas and to keep our server code in line, but it gets even better when paired with TypeScript in the front end in our Angular apps. We've actually went pretty far into the basics of GraphQL, but we still haven't seen really why the word graph was used in the name. There's a great blog post and talk by Devya Pandya called GraphQL Concepts Visualized that goes into depth on this portion. We'll just look at an intro into this idea. In that article, Pandya discusses the idea of the application data graph, which is a graph of nodes and edges representing objects of data and the relationships to each other. A portion of our example data can be visualized in this graph. We have our main object types of employee and client with relationships to their actual data, such as an employee's name or a client's company. But the objects themselves can have references to each other. The two clients have a reference to a sales rep, which is the employee object. This idea is not unique to GraphQL. A lot of data can be represented by graphs and trees and can be very helpful in creating a visual representation of our data. To show how a GraphQL query will extract data from the application data graph, let's look at a query for a client using its ID. We know it will return the company name and the name of the sales rep. This is what the query will look like in our graph. The client highlighted in blue represents the client we queried for, and GraphQL will traverse the tree to the other nodes that we requested. The relationships between these nodes is very important because we can use these query paths to help with client-side caching. There's a lot more that can be said about this concept of an application data graph. This was a short intro, and at least we have basic understanding of the full GraphQL name. GraphQL also provides a tool called GraphQL, which is a graphical, interactive, in-browser GraphQL IDE. It connects directly with your GraphQL server and allows you to write queries and schemas. It also provides full documentation of your schema. It has really nice autocomplete because the schema is typed. GraphQL Playground is a similar tool that is built on top of GraphQL and is starting to ship with some of the GraphQL packages. It just has a few more features. This is the GraphQL Playground being served up from my sample application. You write your queries or mutations on the left. For example, we want to get the first name and last name for all of the employees. When you click the play button, the response is displayed on the right, and we see we have exactly the data requested. Writing the queries and mutations is very easy here because it has full autocompletion. It also contains a Schema Explorer that will show all of your queries and mutations, the values they can return, and the type details of each of the values. This provides instant API documentation for you, and you can even create detailed descriptions in your schema to be shown. For my example here, we can see that the client's query will return an array of client objects. It also shows the type details for clients, so I know what data I am able to request. If you notice, the client has a sales rep, which is of the type employee. This shows how we have data objects containing relations to each other. You get all of this functionality in GraphQL as well. GraphQL Playground just has a slightly different look and some additional nice features like auto-generating curl commands for your queries, which I think is pretty awesome because all of this is really just a post request under the hood. We now have a good understanding of what GraphQL is, how it works, and some of its benefits. Before we can start with our Angular app, we need a function and backend to handle requests. This can be written in many different languages, and the one I made for my example is in Node. If you are interested, I definitely recommend making a simple one yourself, even just for a home project, because it really helps to understand the process. Going into details of how to do this is a bit out of scope for our current discussion. There's also a really great tool called FakerQL that hosts a full-featured GraphQL endpoint you can use to get started right away. You can even go to the GraphQL playground for their endpoint and learn how to write queries and mutations and understand the GraphQL syntax. Now let's discuss how we can use GraphQL with an Angular application. Getting started with GraphQL on its own is actually a bit complicated. It's not batteries included and has a very steep learning curve. Apollo is a suite of libraries and tools that make integrating GraphQL into your apps much easier and brings even more benefits. This is not your only option, but I believe it's the front runner. It has server libraries to handle fulfilling queries and client libraries that provide a straightforward API to create queries. There's even a specific Apollo Angular client that has great support. Apollo Angular now supports ng-add. Running this command will install the GraphQL packages, the Apollo client, and other packages used for caching and making requests. We'll look at some code examples of what is generated and what you need to write. This is the GraphQL module that is generated for you by the ng-add Apollo Angular command. We can see that it is a normal ng module that we are used to. It has a little bit of setup logic for GraphQL. We have our imports first, the GraphQL setup logic, then module declaration with the metadata. Let's look at the code that sets up GraphQL. There are actually a lot of configuration changes you can make here, but the default settings will work for most cases. The only change I made is adding my URL in. I'm just using localhost and the port that my server code is listening on. You would change to either your live URL for a production app, localhost if you're working locally, or you could use the FakerQL endpoint we mentioned before. Next, we have the create Apollo function that performs the setup. This is actually a factory that we will create an options object that we will use later. In the return statement, we first specify a link. This is how we want Apollo to make HTTP requests, because GraphQL, of course, still uses HTTP for network requests. The default value is HTTP link and works very well because this uses the Angular HTTP client to make requests. This provides the benefits of still using your existing workflow, such as interceptors, and this has been great for our platform at RubiconMD because we added GraphQL to an existing code base and was able to reuse our pipe of HTTP logic and authentication right out of the box. Next, we are stating that we want to use the in-memory cache for our client-side cache. This is a normalized data store that has no dependency on Redux. You do not need to do anything else to set the cache up. It will start caching all of your GraphQL queries right away. The in-memory cache constructor can take options objects for further configurations, but this is for fine-tuning your cache later and is not necessary to get started. The module itself is now decorated, and the metadata creates the setup as we normally see in modules. The exports will be used mainly throughout other Apollo files, so you may not even encounter them later. In the providers, we are providing Apollo options, but using the factory that we configured above with a dependency on the HTTP link as we discussed before. Again, this will be used throughout other internal files of the Apollo package, so you don't need to worry about these to get started. Then we just export the module as normal, and it was actually already imported into app module when we ran the ng-add Apollo Angular command. So GraphQL is all set up, and we are ready to go now. We're now ready to create some services for our desired queries. Each query and mutation will be in their own service. This will later keep our components very focused and only have access to their queries or mutations they absolutely need, resulting in very precisely controlled data. Remember, we are trying to limit the amount of data we request down to exactly what we need. Let's break the service down so we know how to make one of these. These imports are pretty clear. Of course, we need injectable, but then we are also importing query from Apollo and GQL from GraphQL tag. Query is the base class we are going to extend for our query, and this will give us all of the actual GraphQL functionality, so we only need to specify the data we are requesting. GQL is a JavaScript tag function. If this is new, have fun Googling JavaScript tags and finding anything besides the script tag for HTML. But I'll explain a little bit what a tag is when we use it below, so there's an example to look at it. Finally, employee is a type I define based on my data schema. We could actually define this interface so we wouldn't need to import it. but it was good for this example to show where it is coming from. Now we are using types on the server for our schema and TypeScript on our front end to always specify exactly what our data will be. The only interesting part here is that the employees query extends query. Again, this is the base class that will provide the methods we need to make the GraphQL requests later. We are passing the query class a type that will specify what our queries will return. The query will return an object with a key called employees that contains an array of employees objects. This is the bulk of the service and the most interesting part. Document is a property that contains your actual query. This is where we use the GQL tag function. So a tag is a function that is called by passing a template literal without parentheses. So it really is just a function, but it is followed by a template literal, which is a string surrounded by backticks instead of quotes. That whole query portion is actually just a multi-line string. This is how GraphQL requires us to define queries and mutations, and will look just like the queries we were writing in GraphQL Playground. We state this is a query. Remember, it could also have been a mutation. We tell it to use the employees query, and we specify that we want the ID, first name, last name, and the company of the clients. That's everything for this service. Like we said, the rest of the functionality is extended through the base class, so now it's ready to go. Using these services in our components are no different than any other service we use through dependency injection. We can get through the portions that are common first. Our standard imports, import the service we just made, and the type we saw before. Also, there's nothing new going on in our component metadata. We're defining a property that will eventually hold the result of our query. We know that our employees query returns an array of employees. Then just inject our service into the constructor. This is where we finally fire off the query, and I'm doing it in ng-on init because I want it to start as soon as the component is ready. But you can do this anywhere that fits the goal of the component. So let's step through this, but it should feel a lot like observables, which we just saw a lot about. So this .employees query is our query service. .watch.valueChanges is just as it sounds. We're saying we want to watch that query and take action when the value of it changes. We then subscribe to the value changes as we would with any other observable, and the query is sent. I'm passing a very simple arrow function to subscribe to assign our query result to the employees property. Now the query will be sent to our server. The resolvers will gather the data that we specified. It'll be fulfilled and returned to the client, and it will be assigned to our property to be used in the template or wherever else we decide. And that completes the first full round trip of requests using GraphQL. The final portion we have time to discuss is client-side caching. This is another topic that can have many talks on its own, so we'll just get into the basics. We saw earlier that in our GraphQL module, we imported and used the in-memory cache from Apollo. This is already enough to get a large amount of functionality without any additional lines of code being written. On the left is the employees component we saw before. This component needs all of the employees because its template displays a list of them, and it uses the employees query we just saw before. On the right is a stripped-down version of my new client component. This also needs all of the employees because when we are adding a new client to the system, we want to look through our employees and choose which one to assign as the sales rep. This component will also use the same employees query to gather these. Since both of these need the exact same data, it'd be silly to hit the server twice. In fact, Apollo agrees with us. The first time the query is made, it'll be sent to the server and resolved as expected. But then the results are also cached in memory client side. Then, when the second query is made very soon after, Apollo will recognize that all the data is already available and serve that request from the client-side cache. The components that request the data never know if the data came from the server or the local cache, and they don't care. So in our example, we don't need any logic. We don't need to add any logic to the second request to make sure that it is served from cache. Apollo will handle this out of the box. We didn't go deep into mutations, but that's where the cache will get even more interesting. First, it's important to note that Apollo assigns unique IDs to all of our data objects when it first receives them from a query. So then let's say we write a mutation that updates the last name of an employee. When we send the mutation to the server to update the name, it also uses the ID to update the name of that object in our local cache. If we look at our examples here, we called this .employees query.watch.valueChanges, so we are watching those queries. After that mutation, the value of the employee's query changes, and both of these components will be updated with the new last name of that employee. The update comes from the local cache, not from hitting the server again. We'll make the mutation, update the server, update our cache, and then even update our views without the need for any additional code to write. Caching is a much more in-depth topic, even outside of GraphQL. But we can end on the point that the basics provided to you from Apollo get you pretty far before you have to start adding more logic. It's been a great way for us to simplify how we manage our local data store. This, along with some solid performance improvements and greater control over our data, has already made GraphQL an integral part of our core platform at RubiconMD, and I've had a lot of fun working with it. The code I use for my examples is on my GitHub, and it is linked here. Feel free to check it out, and I hope it's helpful. Thank you very much for your time, everyone.